Today is the 8th of May 2024, and this will be our fourth video on standard index form. Okay, we've done some questions earlier. I introduced it in the beginning of the videos. Possible exam question. There was a question that I solved, that I looked at it. I think I solved it in two different ways or something. Okay, but I found the need of uh, doing some videos on that, because some of the questions they might just ask you leave it in the standard form, and at times you people get the answers and then they leave it and then they lose 1 mark. Okay, I want you to get as many marks as possible that can put you in the range between A star and C. Okay, if it's Gcse you want, at least you are capable of achieving that or even more. There is no need to go back for a receipt. Okay, so before I start the lesson, thank you everyone, to all my subscribers. Please, if you haven't subscribed, subscribe please. Share, like, follow, okay, so that we can circulate on the platform and help more people. Okay, if you've got your Gcse this year, next year to be somebody's turn. Okay, and these things circulate. One day it will be your child's turn. If you don't help us circulate it, what happens when it's your child's turn and the platform is not there? Okay, when this could have been there to help you. Okay, because I'm not going to take it out, it's just going to be there. Okay, as many as who need it can just go on and use the topic. Okay, you can just go on a topic and watch it. Okay, please, if the account is not yours, ask permission from the account holder. It's very important. And follow my notes last script. Okay, so this here today is a cyclic theorem, which I'm bringing as the starter. Okay, we know that all the three angles in the cyclic quadrilateral add up to 180. Yesterday, the starter we had, I had to put it in the comment section because I think on twice I said we had a cyclic quadrilateral, and then on two occasions I said I think I was going to talk about 115. So I said two opposite angles in the cyclic quadrilateral add up to 115. It's not 115, it's 180. Okay, so the 115 plus the other angle should add up to 180. So I wrote it in the comment section. Okay, so it's very important to follow the notes. Okay, and I know you have this theorem already, so um I have said it over and over again. If you follow my notes, you won't go wrong. Okay, because everything is right there in the notes. Okay, I'm just trying to explain and tell you how I solved it, so that if you also have another way that can make it easier for you, then, because the more you explain these things, some people answer questions and they don't even understand it. But I believe the more I explain to you and you understand it, it stays with you longer. So that even if you don't revise it, maybe the day before or a week before, immediately you get into the question, um, you can hear the replay in your head so that you can do it right. Okay. Please beware of scammers. Please don't fall for them. We are not soliciting. I'm not soliciting for funds. Okay. If I say we, it's uh, the people around me, my family. We are not soliciting for funds for this platform. Okay. I guess felt like um, I can do that. Okay, and just put some videos out there to help people who can afford the extra tuition. Okay, so there we go. So the recap I'm going to talk about is what we did in the last video. We changed ordinary numbers into standard form. So maybe if you have 0.045, okay, what will be, how will you change into standard form? That's what I did last lesson. And then I think there was a question as well, 0.0465. I mixed the 5 in the end, so I don't know what happened there. Okay, but today I'll try and be careful so that I don't miss anything. Okay. This diagram is not to scale. Okay, if it's to scale, I'll tell you. Most of the diagrams I bring here is not to scale. Okay, because whether if it's to scale, it doesn't matter. It doesn't affect the question. Okay, so if we have to draw it to scale, then I'll tell you and tell you the measurements. But if it's not to scale, I'll also tell you. Before I even find out what we are doing, I can look at the diagram. So what is here is a circle. Okay, it's a cyclic um, theorem question. There is a triangle O B O A or A O B. There is a tangent that goes through A, which is CA. Okay, we can put the letter here. Okay, now they said this is 2x. Okay, that one. And we know that the tangent at A, the whole of the two angles, will be 90. So if that is 2x, okay, then that'll be 90 minus 2x. I'll go a bit slow so that I don't miss anything here. Okay, now this is a chord. A, B is a chord, and is having two lengths from the center. So from one of the cyclic theorem, OB equals OA, the length. So if this side is 90 minus 2x, then this side will also be 90 minus 2x. So to find the total angle, or to find the angle in the distance, it should add up to 180. So 90 minus 2x plus 90 minus 2x should add up to 180. 180, no, not 190, please. 180 degrees, please. Now let's see what the question says and what we are supposed to find. So I've said A and B are on the circumference with center O. And CA is a tangent on the circle, which I've told you. CAB is 2x, so CAB, that angle here is 2x, okay? I told you earlier videos is the angle in the middle, so it's the angle at A. If you have CAB, so if they have COB, then it will be the angle at O. Now here prove that the angle AOB is 4x. So that's and give reasons. So angle AOB, so that one. So for us to find this angle, we have already said the angle at A, this angle here, is 90 minus 2x. That angle here is 90 minus 2x. So if we add both of them and we subtract from 180, we should find the angle at O. Now we have to give reasons, and I've already talked you through the reasons. Okay, so I'm going to start answering the question. So show that AOB is 4x. Okay, the angle of we should look at the diagram and why. So angle AOB, OAB, that is the angle at A, okay, is 90 minus 2x, which I have shown you. The angle BCA is 2x, okay. The angle OBA is 90 minus x, okay. And then angle OAB is isosceles. So what it means is, because this is joining a chord and is joining from the center, that length and that length will be equal. So if that is 2x, that would be 90 minus x, because that is a tangent. And that is also 2x, 90 minus x, because this angle and this angle are equal. So something added to 90 minus 2x plus another 90 minus 2x should be equal to 180. Okay, so that's the angle at B, the angle at A. Okay. So angle OBA is 90 minus 2x. Okay, because the triangle OAP is isosceles. That is the reason I gave. Since total angles in triangle is 180, that is the sign for triangle. Okay. You can have your own sign. Some people have different signs, but normally I draw a small triangle if I'm in a fast, if I have to write a bit faster. Because I'm presenting to you, I don't write a lot of shorthand, but assuming I were making notes, okay, I would put in a lot of, I have a lot of shorthands I've developed over the years that makes me write a bit faster. Okay. So angle OAB now will be 180. Okay, and the two isosceles angle in the triangle minus 90 minus 2x minus into bracket 90 minus 2x, because 90 minus 2x is seen as one number, one angle, one figure. Okay, it's seen like 45. So whatever the 2s's is not known. So the 90 minus 2s, the takeaway should affect that, the whole of 90 minus 2x, and it also should affect the whole of that. Okay, so now 180 minus, so minus here will be minus 90 plus 2x, because the minus will affect everything in the bracket. So is this one. So minus 90 minus 90 becomes minus 180. Minus 2x plus minus 2x will be 4 plus 4x. Okay, 180 will cancel out. So the angle at A will be 4x. And then we've proved that. Okay, because it says we should prove and why. So in one case, we made the assumption that it's isosceles, which is true from cyclic theorem. Okay, we also made an assumption that the total angle should add up to 180, which is also true. Okay, so as you solve, you put all this inside. So here is your diagram now. Okay, and this is how I solve this. Okay, um, that is the question why. Okay, this is how I solved it. Okay, so if you follow this, you can't go wrong. Immediately you set your reasoning right, everything becomes calculation, unless you miss the negatives here. You should arrive at the angle at O or AOB in the triangle, that is the angle at the center, to be 4x. Okay, so AOB is 4x, so we've done that. Today we are going to continue with the standard index form. We are going to look at adding. When you have a standard form, how do you add? Okay, then we'll do the subtraction, we'll do the multiplication, we'll do the division. Okay, and then from there we would just do a few questions, and then the rest of the questions I feel is challenging, we'll look at it at exam possible questions the next set, or we will just if it's short, we'll use the starter to just handle some of those. Okay, now let's look at what we are doing today. Okay, so we want to add in standard form. Now the first case is when the powers are the same. What do you do? It's easy. Okay, so if the powers are the same, you add the numbers and you add the powers. You don't, the powers are the same. So here the first example is 2.5 times 10 to the power 3 plus 3.2 times 10 to the power 3. Okay, now 10 to the power 3 will come out. So we add 2.5, add 3.2. So we have 5.7 times 10 to the power 3. Okay, so 2.5 times 10 to the power 3, that is one index number, standard index form, plus 3.2 times 10 to the power 3 will be 5.7 times 10 to the power 3. Okay, now another one. So the adding is straightforward. Okay, or you can convert them into ordinary numbers, add them, and then change them to standard form. Okay, now the second one, 1.5 times 10 to the power 2 plus 1.3 times 10 to the power 2. Okay, so 1.5 add 1.3 is 2.8. Questions like this might come in the non-calculator paper, because these are things you can easily do with a calculator. And then 10.2, you have 10.2 here. So your answer becomes 2.8 times 10 to the power 2. So here, 1.5 times 10 to the power 2, add 1.3 times 10 to the power 2 will be 2.8 times 10 to the power 2. See 10 to the power 2, this as assuming you have 1.5b and 1.3b. You are going to bring the b out. So you end up getting, assuming it's regular, you get 2.8b. It's the same thing. Okay, 10 to the power to 10 to the power 2 can come out, and then you add the numbers. Okay, let's look at another example. 2.7 times 10 to the power 5. Add 1.1 times 10 to the power 5. So 2.7 add 1.1 will be 3.8. Then times 10 to the power 5. You don't add, it doesn't become 10 to the power 10. Okay, as I told you, if you have, assuming this is 2.7b and then 1.1b, you are going to bring the b out if you are adding. It's the same thing. 10.5, you have to bring it out because that is the common power. And then you add the numbers and then you get your answer. So now that is what you are going to get. Now the next question, 5.3 times 10 to the power 4. Add 2.4 times 10 to the power 4. Again, 10 to the power 4 will come out. 5.3 plus 2.4 becomes 7.7 times 10 to the power 4. Okay. Now, another case in the adding scenario, okay. In the subtraction that I think I'll introduce tomorrow, okay, it's the same thing. It's just that you subtract the numbers, okay. Now, you can change the number to ordinary number and add, okay. So 2.5 times 10 to the power 3 plus 3.2 times 10 to the power 4. Note here, 10 to the power 3 and 10 to the power 4, the powers are different. So which one are you going to bring out? The powers are not the same. Okay, so now I'll change 2.5 times 10 to the power 3 to an ordinary number. Okay, so 2.5 times 10 to the power 3, it is, I'm going to move, because it's a positive power here, I'm going to move the decimal 3 times towards my right. So I have 1, 2, 3. So now I've got 2,500. 3.2 times 10 to the power 4. I'm going to move the decimal 4 times. So I rewrite 3.2. 1, 2, 3, 4. So I have 32,000. Okay. So now, both of them together, 32,000, add 2,500. Okay, this you can do it without a calculator. Okay, because they are clean as numbers. All you need to do is to put them in the order that they appear, the place value, and add. So if you do that, you are which we've done earlier on. Okay, So you get 34,500. Then you change back. Okay, you change it back. So now 34,500. The decimal is here. So I have 1, 2, 3, 4. So my standard form now will be 10 points. 3.45. Okay, please don't forget the last number. Last video, I realized that I was just missing out the last number. It's not a good habit. Okay, I wrote it down, but I was saying it. So, as I said, make sure what you are thinking is what you are writing. Okay, so now we have 3.45 times 10 to the power 4. Okay, that is when you have different powers, and then you cannot bring, you don't have like the one we did earlier on, when you have one power that you can just bring one and add the numbers. So here you would change the numbers, and then when you finish you put it back in this number. Okay, now, or you have this number 2.5 times 10 to the power 3, and then plus 3.2 times 10 to the power 4. So you can change one of the powers. Okay, so you can either change um, 2.5 times 10 to the power 3 to something times 10 to the power 4, which will not be in this standard form, but in the end you convert it back. Okay, I hope I'm clear on that. So here, to change 2.5 to the, because this is a power of 4 and power of 3. Okay, so I now have 0.25 times 10 to the power 4. Okay, because if I want to increase 10 to the power 3 to 10 to the power 4, then I have to move it forward, so that when I multiply back, when I bring this back, it becomes 2.5 times 10 to the power 3. Okay, if you don't understand, pause it and just um, look at it for a second. So now this is the power 4, but it's 0.25. Okay, this is already the power 4, and it's 3.2 times 10 to the power 4. So now that I've got both in the 10 to the power 4, I can bring 10 to the power 4 out. Okay, so 3.2 add 0.25 will be 3.45 times 10 to the power 4. Okay, so that is in the standard form already. If it's not in the standard form, okay, assuming I change 10.4 into 10.3 and I kept this 10.3, I won't get the answer straight in the standard form. So I can change it now to an ordinary number and change it back to the standard form. Okay, so 2.5 times 10 to the power 3. Here the powers again are not the same. Add 3.2 times 10 to the power 4 becomes 3.45 times 10 to the power 4. Okay. If you want to use the calculator on this, okay, I don't have my calculator with me. I've borrowed it out. Okay, because exam is coming, so everybody needs to be using their calculator. So I gave my calculator out. Okay, so you have to, assuming you want to do this on the calculator, assuming it's a calculator paper, okay, and you don't have straight numbers, you type first 2.5, then you type the exponential sign on the calculator. Okay, at this point, if you're in year 11 and you're going to do your exam this year, your teacher should teach you this. If you don't know how to do it, take it to your teacher and ask them, can you show me the exponential sign? Okay, so you press exponential and press 3 plus, then 3.2 here, the exponential 4, the same thing, the question. This is the question. So 2.5, the exponential sign, type the exponential sign, put in 3, add 3.2, the exponential sign, put in 4. The 3 and the 4 are the powers. You will get this answer. Okay, go and try it on your calculator and make sure that you've got this, okay, this answer here, so that when you get and practice it several times, so that when a question like that comes and it's on the calculator paper, you can easily use your calculator if you're allowed to. Okay, so this is what I have sharing with you today. Tomorrow we are going to look at the subtraction with the same powers and with different powers as I've shown you today. I might just bring in the same examples that we are doing, okay, so that I can show you it is easy. So if you get whether it's adding or subtracting, and then we'll do another video, a separate video on multiplication, and then we'll do some examples on that, and we'll look at the division. These are questions that you can easily do and get the 3 or 4 marks. Okay, so please subscribe, share, like, and follow. Okay, if the account is not yours, please ask permission or open your own account. Very, very important. And also, beware of scammers. Please take care of yourself. If somebody inboxes and said, can you donate money for orphanage under this platform, or a sick person or amputee, I don't even know what they are talking about. Okay, so don't bother. Okay, thank you very much for and please give us nice comments. I would really, really appreciate that. Okay, some of them make my day. Somebody just said hi. It's very good to be nice. Let's be nice to each other on this platform. We are not creating a toxic platform. If you can't hear me, I'm sorry you can't hear me. Okay, with time, you will hear me. Okay, I promise you. Okay, and with time, a lot of things will make sense on you if you stick with me. Okay, so if you can't hear me and you are doing your exam, you can stay on. With time, maybe after 2 or 3 videos, you will hear me. Okay, thank you very much for watching today's video with me, and I'll see you in the next.